Suppose I want to draw the graph y equals 4. Well, there's actually three possibilities. It's a point on the number line, it's a horizontal line on the plane, it's a vertical plane in 3 dimensions. So knowing the dimension I'm dealing with has everything to do with which of these 3 that I would select. So we want to talk about how does dimension affect graphing in general. Now suppose we want the graph of x squared plus y squared is 16. Well, we know in the xy plane that's a circle of radius 4 centered at the origin. But in 3 dimensions, it's a circular cylinder that goes infinitely in the z direction, but is circular in the xy plane. So it's essentially, I took this circle and extended it forever in both directions. So again, knowing what dimension we're dealing with has everything to do with knowing which of these is correct. Now consider the graph y equal x squared. I know that's a parabola in the xy plane, but if I wanted to make this 3-dimensional, imagine that I'm taking this shape and I'm pulling it out infinitely so that all slices parallel to the xy plane would be congruent and parallel to this parabola. So in 3 dimensions, it would have this effect, and this is what is known as a parabolic cylinder. Again, the term cylinder has to do with the fact that it's 3-dimensional, but only 2 variables are given, which means that it's a 2-dimensional graph extended infinitely in 3 dimensions. Now summarizing, if I know I'm in 2 dimensions, then it's very easy to identify the graph. This would be the graph of an ellipse. I don't actually have to draw the graph, I just have to know what it looks like and how to name the shape. But if I said I want the surface in 3 dimensions, the key word here being surface, that automatically means I'm in R3, then that same equation would be an elliptical cylinder. It would be this ellipse extended infinitely. So the ability to identify a cylinder just means you have to know you're in 3 dimensions, but you're only given 2 variables in the equation.